Okay. Good evening, students.
Good evening, sir.
How are you?
Thanks.
Now was your weekend.
Awesome.
Yeah, today we'll be looking at PD, but before we consider PD, let us try to take note of partial differentiation. Amen?
Amen.
Okay. Yeah, in engineering, happens that the function of one quantity that is talking about, when we are talking about quantity, is the same thing as variable. Just like you have y equals to ax raised to power n. This is independent variable. True or false? This is dependent variable. That is what it means. Yeah. So depends on changes taking place in two or more other entities. For example, you can now see that the volume V of a cylinder is given V equals to pi r squared h. Our r is radius, then our h is the height. The volume will change if either radius r or height h is what? Changes. The formula is this. Can you see now? So it means our V is equals to F of what? R comma what?
Please.
Which means V is a function of R and H. Let's look at some practical examples. Look at it. You can now see that some practical examples include time of what? Oscillations. Can you see now our T is equals to, sorry, this is 2 pi, I think so, if I'm not mistaken. True or false? This is 2 pi, yeah. Time of oscillation, I think so. Alright. Yeah, 2 pi. I'm right. Sorry. This is 2 pi square root of L all over G. This is our T is equals to F of L comma what? True or false? Then top T this is L times alpha. So T is a function of, we can now see that T, this means that T is a function of what? L and what? And alpha. Then pressure of an ideal gas. P is equal to nRT all over V. It means P is a function of what? Yeah, because T is temperature, true or false. Then our V is what? Volume. Then when you look at this, you can now see that this is first order differential derivative, right? Yeah, so that is what we'll be looking at. I'll be looking at first order derivative. It's okay. So now you can now see that a coil D is used to what? Denote a differential coefficient in an expression containing more than one variable. Is that clear?
Yes, sir.
As long as PD is concerned, in differential equation, I mentioned that dy all over dx, this is the same thing as y prime, true or false? If you could remember, then I said this is also the same thing as what? Y dot. So if we have d squared y all over dx squared, this is the same thing as y prime equals to y dot. True or false? You agree with me, right? Yes. So now we are looking at partial derivative When we say partial derivative, partial derivative are always in this form. You understand? Sometimes this means del. We can write it in this form. Or you write it this way. Whichever one you want it to be. Is that clear?
Yes, sir.
So now, here, we can write it this way. Either z all over the x, and this is the same thing as z subscript x. Is that clear? This is the same as z subscript x. So even if you have partial z all over partial y, this is the same as what? Z subscript what? Sometimes you may see partial f all over partial t. It means this is what? F of what? F subscript what? T. So what if you have partial square f all over partial t square? It means this is the same thing as f subscript what? T. Can you see now? It means you differentiated this function how many times? Twice. Partially. Is that clear?
Yes, sir.
So that is the meaning. So we'll go ahead and solve some problem. Is that clear? Let's look at this problem. Example. Find okay, if z equals to 5x raised to the power 4 plus 2x raised to the power 3, y raised to the power 2 minus 3y. Find dy over dx. Okay. Dy over dx. Find partial z all over partial x and partial z all over partial what? Y. If you can see what I am saying, go back to this explanation. You can now see that one quantity depends on taking place in two or what? Can you see now? So look at it. We have more than how many? Two. We have x and what? Y. Two of us. So now, how can we evaluate or find partial z all over partial what? X and partial z all over partial. It's simple as ABC. It's not difficult. How? Because we are going to differentiate this function. They said at first with respect to x, secondly with respect to what? Y. So as long as you know how to differentiate, I don't think you have any problem. So let's get together. So here we now the right solution, right? Our z is equals to 5x raised to the power 4 plus what? 2x raised to the power 3 y squared minus what? 3y. Amen? So let us find this partial z all over partial x, which is the same as z subscript what? X is equals to differentiate 5x raised to the power 4 will give us what? 20. 12 what? So 20x raised to the power of what? 3. Excuse me. Amen. Okay. Yeah. So then let's consider this. Let's differentiate 2x raised to the power 3y squared. Then we have 6x squared y squared. This is a constant, 12 us. This one will be 0 because there is no x there. Because they said we should differentiate partially with respect to what. So now we've gotten this one. Let us consider this. Partial all over partial what? This is the same class. Z substitute what? Y is equal to here will be 0, 2 of us. Y becomes y here. Then let's differentiate this. We are going to have what? 4x raised to the power of 3y. Then differentiate 3y. We are going to have minus 3 equal. Yeah. So all what they need. Is it difficult? Okay, let's move further to consider more examples. Let's move further to consider more examples. Let's add this. Example, another example. Given y equals to 4 sine 3x cos t. Yeah. They said find partial y all over partial x and partial y all over partial what? T. Because the two variables are what? X and what? T. Two of us. So look at it together. Or has anyone finished solving? It's the same approach now, but I know this one include trig functions. This one includes trig functions. Okay, let's look at it together anyway. Amen? Amen. Yeah, let's write solution. You can now see that the function is, we have to differentiate this partially with respect to x and y. And t. Two of us. So it means our partial y all over partial x is equals to. It means we are going to differentiate only sine 3x. So 4 and cos t, they are constant. Do you understand? Because they said you are to differentiate partially with respect to what? X. Do you understand? Yes. So if we are to differentiate, just assume here, we know that we have 4 here. But just assume that this is how it is. This is how it is. Sine 3x. If you differentiate sine 3x partially, you are supposed to have 3 cos 3x. This is what you are supposed to have. Yes. Is that clear? Yes. So now, this is the answer. But we are left with 4 cos t. Two of us. Yes, so we need to use this to multiply this. Do you agree with me? Yes, sir. It means 3 times 4 is 12. So cos 3x times what? Cos t. So it means the answer will now be 12 cos 3x cos what? T. You agree with me? Then the second one is partial what? Y all over partial t. It means
4 and sin 3x are constant.
yes. So if you differentiate cos t, what is supposed to have? Minus what? Sin t. True of us. So use it to multiply this. So you are going to have minus 4 sin 3x sin what? T. True of us. So this is the answer. Is it difficult?
So if you have differentiation, if you have cos, it will change to sin. If you have sin, it will change to.
I think we did that.
Yes, I did that.
We did that in our ending. So, can I clean this? I can clean this and write yes? Okay. So let's solve more examples. Let us solve more examples. Okay. We have some examples here.
So I have a question.
Yeah.
I was thinking 12 cos 3x was constant.
Huh?
And the y, the other
Yes.
Yes.
No, now you are not coming back to differentiate this one. If you are coming back to differentiate this one, it means you are going to have partial square y all over partial x squared. Do you understand?
I understand.
So it means you are still differentiating this. We are going there now. But this one, we are to differentiate partially with respect to t independently. So after you obtaining this, you come back to the function again. Look at it. You obtain this one. You understand? So just take note. Okay. Let's have another question. Given sign. Okay. We'll carry it. Another example. Given z equals to 4x squared y raised to the power 3 minus 2x raised to the power of 3 plus 7y squared. Find 1 partial square z all over partial x square. 2 partial square z all over partial y square. 3 partial square z all over partial x partial y. And 4 partial square z all over partial y partial x. It's simple as ABC. Amen. We'll look at it together. It's not clear. It's very simple. Oh, Brasilia. You are watching from Brazil. Thank you. You are welcome. If you have any question you ask, just drop it there. I'll get back to you. Okay, so let's move further to solve this problem. Let's move further to solve this problem. Is okay? Yeah, the question is, let's write solution, right? Z is equals to 4x raised to the power of 2y cubed minus 2x cubed plus
7y
squared, right?
Yes, sir.
Okay, yeah. So let's look at it together. 1, they said partial square z all over partial x squared. So it means this is the same thing as partial. We are going to first differentiate this. This means differentiate this function how many times? Twice. That is why it is square. Partial square z all over what?
Partial x squared.
S squared. Amen? Okay. So if you agree with me, it means let us take the first partial derivative with respect to what? X. That is when, listen, that is when we can now obtain the second partial derivative. Is that clear?
Yes, sir.
So let's differentiate this function partially. Partial z all over partial x. We're going to give us what? 8x y cubed. Then here will be minus 6x squared. This is what? Constant 0, right? Then we have to differentiate this function. Yeah? That is where your question, the question you asked. So we now take it from here. So here we now, this is how it will be. It means this is, let's just do it this way. This is the same thing as z subscript x, isn't it? Equals to what? 8x y cubed minus 6x squared. Right? Then it means here we now be partial all over partial x times partial z all over partial x. Can you see now?
Yes.
It means, this means that differentiate this. And this is what? This function. True or false? So if now we differentiate this, this will now give us partial square z all over partial x squared. Then this is the same thing as well. Z subscript xx, isn't it? Then this is equals to, we are differentiating partially with respect to x. So if we differentiate this, we are going to have what? 8y raised to the power 3. Then differentiate it minus what? 12x. True or false? Do you agree with me?
Yes, sir.
Okay. So that is that. We are gotten this. What they asked us to find. That's it. So let's move further to consider this one. Yeah, the second one. Is that clear? Okay, so let's consider the second one. It means we are going to differentiate it. Partial z squared. But we first we have to differentiate it once before we. So it means we will come to the original function. We are now differentiating partially with respect to what? Y. So here will now be, if we differentiate, we are going to have 12x squared y squared. True or false? Here will be 0. True or false? Because there is no y. Then here we are going to have plus 14y. True or false? Then it means this is the same thing as z substitute what? Y is equals to 12x squared y squared plus what? 14y, right? So now this will now be partial partial y, open bracket, partial z all over partial y now be equals to partial square z all over partial y square. Amen? Amen. Then this is equals to z substitute y. We have to differentiate this one. True or false? So if we differentiate this, we have 24x. 24x raised to power what? 2 plus differentiate for 14y is 14. True or false?
True. Now, if it is 2, you are not going to minus anything. Because this x is squared.
Which one?
This one.
This one?
Yes,
X.
sir. Yes,
We
sir.
don't after x now, we after what? Y now.
Okay.
Do you understand?
Yes, sir.
Any question? No question?
This one is very sweet. But if you compare it to Laplace, kai.
With respect to my yes.
Laplace is tough. You sure?
I don't want to be the
Okay. Yeah. We have number 3, right?
Yes, sir.
And we consider number 3 and 4. Is that clear? So now number 3 and 4 is this. Look at it. Number 3 and 4. It means this partial square z all over partial x partial y means that already you differentiated x, true or false. So it means go ahead to differentiate partial y in the what? Yeah. That is what it means. Is that clear?
Yes, sir.
Because partial x before partial what? Y. So for us to get this partial y, it means we have to come in. So this implies that partial square z all over partial x partial y is the same as z substitute x y.
Yes.
Is that clear?
Yes,
sir.
So this is the same thing, and this is equals to, let's come in.
FXY2.
So it means we are differentiating this with respect to what? Y. Is that clear? That is why you are saying partial y at the end. So if we differentiate this with respect to y, what are we going to have? 24x, isn't it?
Y square.
24x y squared. This is what we are supposed to have. True or false?
True, sir.
Then this other one says what?
Yx. Partial square.
Partial square what?
Z.
Z all over partial y partial x. So this is z partial substitute y x. This is
X.
we will see how it means we are coming here. True or false?
Yes.
True or false?
True, sir.
Because partial y before partial x. So we have to come here. So we are going to have what?
24
24
y squared.
24 x
X1.
24 x square y. True or false?
True.
Huh?
Yes, sir.
Yeah.
24x y squared.
X y squared.
It's not square. It's not square. Now I
Let's
can
do it again.
So what? This
Right,
is
respect
already
to x.
Respect to what?
Yeah?
Respect to x.
No, it's equal to y.
The first one is respect to
Okay, yes. Sorry. With respect to x. Sorry, you are right. So, thank you. So it means it's going to be what? 24x y squared. Yeah. So you can now see that this and this are equal. True or false?
True.
Any question?
Oh, very, very sweet and nice.
Very simple.
Yes, sir.
This one is just like a stepping stone.
It's either.
These ones are stepping stone. So just enjoy yourself. Now I want to go into
No, I'm coming.
we want to go into right. What?
Yes. Yes.
You never know.
Okay. I understand.
So now we are done with partial differential. We want to look at partial differential equation. So,
Sir,
students,
I want this one. Which one is number 1 and number 2?
look at it now. Look at it from where now. This is 1.
Okay.
This is 2.
And
This
this
is
is
3. And this is 4. 3 of us. Okay? So now we now consider partial differential equation. Right. This is the marker. Okay?
Since I have a question.
Yeah, ask.
This one you said partial square. When we differentiate what 2 times is it second order differential equation?
This is not the differential equation.
Okay.
You understand?
I understand.
This is not the differential. We are going to partial differential equation now.
Thank you.
Yeah. A partial differential equations are those equations which contain partial derivative. Partial derivatives. Independent variables independent variables. The independent okay. My X and Y and the dependent variable by
So it's only capturing the side. The camera is only capturing this side.
no,
It's no solution.
the partial differential coefficients are denoted as follows.
I roll and x and the dependent variables.
X and Y
Okay.
partial Z all over partial X is equals to P. Then partial Z all over partial Y equals to Q. Partial square Z all over partial X square equals to R. Then partial square Z all over partial X partial Y equals to S. And partial square Z all over partial Y square is equals to T. So we consider method of forming PD. By elimination of arbitrary constants. Arbitrary constant. 2. By elimination of arbitrary function. Okay. Yeah, this is where we go here. Okay, now we can consider partial differential equation. I believe with the concept of partial differential derivatives, this will help us to know more about partial differential equations. Amen. Okay. You know very well that partial differential equation, uh, we can have it in this form: partial square y all over partial square x equals to c. This is also known as PD, partial differential equation. That's the second order PD. Is that clear?
Yes, sir.
So these are partial differential equations. But now let's look at it. A partial differential equations are those equations which contain partial derivatives. You understand? Partial derivatives, independent variables and dependent variables. Amen?
Amen.
Okay, the independent variables will be denoted by x and y, and the dependent variable by what? Z. The partial differential coefficients are denoted as follows. Take note of this. Partial z all over partial s means p. Take note.
Yes, sir.
Partial z all over partial y means what? Q. Partial square z all over partial x square means what? R. Partial square z all over partial x partial y means what? X. And partial square z all over partial y square it means what? T. Take note. But how can we form PD? PD, we can form PD using two methods. Is that clear? One of the methods is by elimination of arbitrary constants. Do you understand? Yeah. Why? What do you mean by arbitrary constants? You know, when we have a function of z equals to, let me say, x minus y all in square plus a square equals to b square. These, amen? These are arbitrary what? Constants. Is that clear?
Yes, sir.
These are what? Arbitrary constants. So we have to eliminate this. That is where we can now form the PD. So now we have, by elimination of arbitrary what? Constants. By elimination of arbitrary what? Function. Is that clear? So it means if now example of arbitrary function, either a squared, it's supposed to be a squared. So now if we want to talk about arbitrary, assuming we have function of this form, it's a function. You understand? So these are arbitrary functions after the okay. Okay, so I can clean this, right? Yes, sir. So that we take some examples. So what we want to consider is one, by elimination of elimination of
Literally.
arbitrary constant. Arbitrary constant, right? Okay, let's fix idea of this example. Okay, example. Find the PD of all sphere. All sphere. Okay. Whose center lie on Z axis, amen, and given by equation, is our markers, given by equation x squared plus y squared plus z minus a all squared equals to b squared, where a and b are constants. Amen? Okay, I think the way the weather is changing, you can close with this example. Is that clear?
Yes, sir.
Okay, so let's look at it together. As simple as ABC.
So is it A Z minus A or Z minus 9?
It's
Z minus A.
minus A.
I don't have
So x squared plus, now we are using, notice, we are using elimination of arbitrary constants. Okay. So now let us differentiate this function partially with respect to x. Is that clear? If we differentiate this function with respect to x, here we are going to have 2x, here will be 0. Then differentiate this, we have plus 2 open bracket z minus a partial what z all over partial x equals to 0, because this is 0, right?
Yes, sir.
Okay. Can you see now? So now, this means that if you can see what I have said, use this to divide 2, use 2 to divide 2.
Minus
Divide
both side by
2 by what? 2 bar. So it means you are going to have x plus z minus a partial
Z all over partial x.
equals to what? 0, right?
Yes.
Okay? Then the same thing applicable.
Yes.
We differentiate this thing partially with, okay? So here, let's look at it together.
Yes, sir.
Here will now be what?
X Z X.
No, partial z all over partial x
Yes.
is what?
ZX.
No?
Okay.
What is that?
B.
And then,
Okay.
you propose.
Partial z.
So note that partial z all over partial x is equal to b. So here will be x plus z minus a open bracket p equals to what? 0. Amen?
Amen.
Then, if this one crosses the sign of it becomes minus, right? So z minus a p P is equals to minus X. Then divide it by P. Our Z will now be A equals to minus X all over P. True or false? Then let us consider this other one. We differentiate with respect to us.
X, now we are going to do what's respect of Y.
Y, right? So if we do that, we are going to have here will now be 2y plus sorry, 2 open bracket Z minus A partial what? Z all over partial Y equals to what? 0, right? Yeah.
So this actually is
Assume.
this square.
Yes. You agree with me?
Yes, sir.
So if we divide 1 by 2, we left with y plus z minus what? A. What is our partial z all over partial y?
Q.
So here will be q equals to 0. Amen.
Amen.
Then, so if you agree with me, it means our z minus a q is equals to minus y. Oh, sorry. Sorry. Let's not do it that way. Let's recall. Here we have z minus a. Our z minus a is equals to what?
Minus X over P.
Yes, so here we now be y minus x times q all over p equals to 0. So this is now, we look for SL. So this is yp minus xp is equals to 0. This is the PD they asked you to inform. Okay, thank you for watching. Like and subscribe. Love you guys. Bye. Thank you.
So we have a
Yeah, ask.
Yes.